Let's discuss one problem. Let capital G be a non-empty graph. Okay, that means number of vertices are more than or equal to 1. In such conditions, statement number 1 is, if G is disconnected, then G bar is connected. True or false we have to identify. Second one, if G is already connected, then G bar is disconnected. So whenever these kind of problems are given, first of all you should understand that G represents any graph. Okay, so if you really want to say that statement 1 is correct, then we have to prove that whatever the graph is disconnected, its complement should be connected. Okay, students do these things in a wrong way like this. So some student argue like this. He will take one graph A, B, C, D and he says that, sir, see, this is a disconnected graph. Then I say yes. Then he will compute G bar. You know how to compute G bar, isn't it? So let's try it. A, B, C, D. Okay. That student knows how to compute G bar. Then he will compute like this: AC and C to B and B to D and A to D. We know how to compute G bar, right? Then he says that, see sir, G is disconnected graph, G bar is connected, hence proved. That's a wrong argument. By just taking one example of graph, and if you prove this thing, it doesn't mean that it is always correct. Isn't it so? So what can happen is, there may be some other graphs which you did not even imagine, that graphs may be disconnected, because there are infinite graphs, right? So among them, few graphs may be like this. They are disconnected, but its complement also may be disconnected. Who knows? Did you check them? No. Without checking them, how can you say about that kind of graphs? So that's why finally what I want to say is, your argument is wrong. To prove that some statement is correct, it should be true for every graph. But by taking one example, you are only proving for one graph. That's why it is wrong argument. Then let's observe one more graph. Okay, but as a student, how to solve this problem I will tell you. Take one more different graph like this: A, B, C, maybe D. Okay, single vertex. Then let's try to compute G bar. Okay, then what you get? AD might be, I'm trying to calculate complement. So A to C, yes, then B to D. Then slowly I'm getting confidence that, one more thing is what? D to B, D to C, yes, D to C. So I'm slowly getting confidence that S1 is correct. Okay, so that is what, but I have no proof for that. Then how to prove it? Without proving, I can't say it is correct. So now slowly try to get the proof for it. Okay, initially you tried some examples, and whatever the example you are taking, then its complement is becoming true. That means it is complement is becoming connected. Any disconnected graph you were taking, its complement was becoming connected. Then it doesn't mean that you proved for every graph, right? Be careful. Then now what should be your argument is, since your confidence is about its correct statement, then try to prove it. So how to prove, I will tell you. So that's the main goal of discrete mathematics, especially graph theory. In this graph theory, you will be learning lot of proving techniques. Okay, in entire this graph theory, I'm going to use majority of the time one common proving technique, that is proof by contradiction. Most of the time, sometimes I use some different mechanisms, try to adapt them, try to learn them. Okay, so what you do is, attend my lecture and give a thought for everything. Whenever I give some statement, apply your brain and think a lot. Okay, and follow me. At the same time, you have to apply your own brain to construct the things. Okay, first understand what I'm saying, then think in the same lines as how I'm thinking. Let's begin with that thing. If G is disconnected, any random graph G is disconnected, then why G bar is connected? That is what we have to prove that. Then let's start with G bar. Okay, in G bar, in G, since G bar is connected, right? Assume that, let's say, really G bar is disconnected. Okay, and G is also disconnected. Then definitely statement 1 is false, isn't it? Because the statement says that whenever G is disconnected, G bar is disconnected. Let's take G is disconnected, G bar is disconnected. If it is possible, then only S1 statement is wrong. right? Understand my point? The claim of the statement is whenever G is disconnected, G bar should be connected. Let's say that claim is really wrong. That is called proof by contradiction. Then G bar should be disconnected, G also should be disconnected. Really such graph exists, let's say that is G, then we'll focus here. G bar is disconnected. Then I ask one thing. Which kind of graphs are disconnected generally? When graph has minimum one vertex. Already I told you, whenever a graph is disconnected, then there is no path between at least two vertices, because between every two vertices there is a path, then that graph is connected. Then definitely you should see at least two vertices like Raju, comma, let's imagine them as real world characters like Raju, comma, Rani. What's the property of Raju and Rani? Let's say Raju and Rani are two vertices which doesn't have any path. If Raju and Rani, even Raju Rani has a connection or path, then G bar cannot be disconnected, isn't it? Whenever G bar is disconnected, there exist at least two vertices, Raju, comma, Rani. So they should not have a path. There is no path between them. You understand this point? Let's say really it's possible. Let's say then same Raju Rani should be part of G also, right? Let's represent Raju Rani here too. Okay. So this is Raju and Rani. I don't know whether they are connected or not here, because G is disconnected, then this Raju Rani may be connected, may not be disconnected. Don't say that Raju Rani are disconnected. Then I ask why. Then you say, sir, it is disconnected graph. In disconnected graph, some two vertices are not connected. It doesn't mean that they are Raju, comma, Rani, right? So that's why. But I know that in G bar, Raju and Rani are disconnected. That is what is the starting point. But same Raju Rani may not be disconnected here. They may be connected, may not be connected. Maybe some other two vertices are disconnected. That's the reason this graph G is disconnected, not because of the reason Raju Rani. But my assumption is Raju and Rani are the main reason for this graph's, let's say, disconnection. Whose disconnection? G bar. I don't know about Raju, comma, Rani in G. Whether they are connected or disconnected. Okay, let's start with this point. Then I prove that whenever Raju, comma, Rani are disconnected, so what happens? Let's go to G. Okay, so let's go to G. In that Raju Rani, case number 1. In case number 1, this Raju Rani may be connected. Second one, case number 2, where Raju, comma, Rani are disconnected. Okay, so let me show case number 1 as connected. Case number 2 is what? Raju Rani disconnected. First assume that case number 1, Raju Rani are connected. If Raju, comma, Rani are connected but graph is disconnected, now stop the video and think. Raju Rani are connected but overall graph is disconnected, then definitely there will be one more connected component, isn't it? Otherwise, if there is no another component, then there is only one component, graph will be connected. So that's why I can see one more component in this graph. Then let's say that component will have at least one vertex. Let's call that vertex as Rakesh. Understand my point? Sir, what if Rakesh doesn't exist? Then no vertex exists in this component. Then every component should have at least one vertex, otherwise it is not component. Then no component will be there. Then you will have only one component. But we know that in disconnected graph there exist at least two components. Sir, null graph will have 0 components. See the assumption. Number of vertices are greater than or equal to 1. Then there is no null graph. Then all other graphs will have definitely at least 2 components. Let's say this is component number 1. Then there is another component, let's say, that is this one. In that Rakesh is one vertex. Then I would like to ask some questions about relation between Raju, comma, Rakesh. Since Raju Rakesh belongs to different partitions, then since Rakesh is part of G, he also should part of G bar, because G and G bar are designed on same vertex set. Then my question is, here Raju Rakesh are not connected. directly or indirectly, then definitely there should be direct edge between Raju Rakesh. That's a property of G bar. Whenever there is no edge in G, definitely there will be edge in G bar. Similarly, since Rani Rakesh are not directly connected, and definitely there will be a direct edge between them. Initially your assumption was Raju Rani doesn't have path, but I can prove that there is a path. Remember, right? Initially you assumed that Raju Rani doesn't have path, but I proved that there is a path. In which case, when Raju Rani are connected here. Let's take the second case. What is the second case possible for this Raju Rani? The second case for Raju Rani is Raju Rani belongs to different partitions. What if Raju Rani belongs to different partitions here? Let's say Raju belongs to one partition, Rani belongs to one partition. Then it's very easy. Since there is no edge between them directly, that's the concept of two different partitions. Then directly Raju Rani will share an edge. Hence Raju and Rani are again connected. Now see, whatever the case you take, now let's summarize the concept. Whenever G bar is disconnected, always you should prove that there are two vertices, Raju comma Rani, correct or not? And there is no path between them. Whenever there is no path, then I will go to G. Then I will see two cases. One is if Raju Rani are two vertices, maybe they are directly connected. If they are directly connected, already I proved that here also they are connected through Rakesh. If they are not directly connected, then again I proved that Raju and Rani are directly connected. So that's the story. Finally, what it says, whatever may be the reason, Raju Rani, that means Raju Rani should be connected. But if graph is disconnected, definitely there should be two vertices which are not connected, but you are not able to show them. Why? Whenever you show them, I am proving that they are connected. That means what? You are the loser. That means always you lose the game if you assume G bar is disconnected. That means whenever graph is disconnected, G bar cannot be disconnected. Whenever G bar is disconnected, you should show two vertices Raju Rani. Whenever you show two vertices Raju Rani which are disconnected, then I will go to G and I will come back and I prove that Raju Rani are connected using two cases. And if you don't understand it, don't worry, again see this video, you will definitely understand it. But whenever you don't understand a point, stop the video and start thinking. So this entire graph theory is about improving your thought process. So that's why keep learning and keep thinking. Okay, let's see second statement. If a graph is connected, then G bar is disconnected. Really this statement is correct, then it should be true for any graph. Okay, so what I do is I take one example graph with very less number of edges, but I connect it somehow. Example, this one. Okay, yes, this is a graph G and this is connected. To connect it, I have taken as less number of edges as possible, and I would like to observe G bar. Is this G bar is connected or disconnected? I want to observe. Let me do it. 1, 2, 4, 3, 5. Okay, so between 1, 3 there is an edge. Between 2, 4 there is an edge. Between 5, 3 there is an edge. Right? Between 1 and 4 there is no edge here, means definitely there is an edge. Already see it's connected, and a few more edges I supposed to add to this one, right? So what I want to say is this graph G is connected, its complement also connected, but the statement says that whenever a graph is connected, its complement is disconnected. That is false. The reason, we have an example. Understand? So finally, this is not always true. Whenever some statement is not always true, that means it's false, right?